Okay. Um, so, Project Eliza has been a stunning success, I think, so far. Clearly, people are already quite interested. But there have been some very obvious things revealed to us that we need to work on. There are a few bugs. There's a few annoying things that, as much as we're trying to fight them, we are baked into the model of GPT-3. And also, she just lacks like some basic factual grounding. What I'd like is for to be able to say my eyes are blue, and she's like, okay, your eyes are blue. Later, I can go and talk to her about other things completely unrelated, but she remembers that about me, not just about anybody, but like she remembers facts about me specifically that makes it a more personal conversation without having to also maintain hundreds of lines of text. Like the big problem, if you think about like your feelings about somebody, you don't remember everything they say. You just kind of remember how you feel about them, and that's because you have to compress all of this complex data into like a pretty short, into a pretty small space inside of your brain. And so this is happening all the time. We can learn from this. We can do a similar kind of thing. We're going to create a secondary loop. We need this loop to not be too expensive. It needs to not block our main loop. The main reason we don't want to block our main loop is because we need to like make sure that the response is still fast. So we'll try and actually do all of this factual stuff pretty quickly, and like the actual processing judgment, whatever. We'll do that after our response. And so we're always kind of responding and then thinking about it a bit, storing that information, and then we're kind of primed up for the next response. And that's how we can keep the responses really fast. So the things we have to do are we're going to use the event system to store facts. Um, when we store a fact, we also have to like determine what a fact is. There's a lot of ways we could do that. In traditional NLP stuff, there's a thing called named entity recognition. How do I look through a piece of text and determine like, oh, you're talking about Paris, you're talking about air travel, or something like that. So there's named entity recognition. And there's also just like guessing the topic or matching the topic. And that can be done. Named entity recognition can be done with a lot of different models, but there's also specific models for it. And we have some of that stuff in Thoth, but also GPT-3 is extremely flexible and good at named entity recognition, especially. And then there's also like topic matching, classification, different stuff like that, which can use like in basically sentence embeddings. Or and those are trained in a very similar way. We can either use like Facebook's BART model, which is another transformer, or we can again use GPT-3. And I think that right now, to keep things simple and avoid having to add any other API keys, I think we're going to use a cheaper model of GPT-3 and just try to get facts to work well. So the first place I'm going to start, I have this brain, and we're going to add it here. But I actually think that we probably just want to go to the sandbox. Um, you know, like we just want to get something going that gets. Let's just like make sure that we have some sort of prompt that gets facts out of the thing. No, there's no examples that are really going to help us. We're just going to have to go to the playground. So we're going to start with something really simple. I'm just going to start with like moon. My eyes are blue, right? And then we'll say Eliza. Oh, that's really neat. This is, I don't know, something you'd probably say. If I had eyes, I think that they would be, I don't know, what color would her eyes be? I'd say, let's just say brown. It's probably the most common, because it's the most common color for human eyes. Okay, cool, that's logical. So then we need some sort of prompt to extract. Well, there's actually there's two things here. We want her to know that my eyes are blue. We also want her to know that her eyes are brown. Do we want her to know that her eyes are brown? That's kind of cool. I kind of like that. Now, I would imagine we could even like share that with other prompts somehow. And maybe we could even, instead of running 2 different GPT-3 prompts here, we create some sort of format where we can get the facts, and then we can actually extract them for both her and me. But then also, we're trying to make sure that she doesn't confuse the facts of her and me, because like one of the other problems we've had a lot of is that 2 people will be talking to her, and she'll be like, "Oh yeah, you just talked about your red car." It's like, no, that was the other person talking about their red car, because she doesn't have a strong sense that they're different entities with different ownerships. She's just a likelihood estimator going off of the words that were injected into the prompt before. So, cool. My eyes are blue. Oh, that's really neat. If I had eyes, great. So we just need some sort of prompt. Task. Okay, another cool thing is that we will do some dynamic injection of names, so that we know that we can put Moon in the task later, right, dynamically, and then replace that with my username on Discord or whatever, wherever I'm coming from, so that it's she has some sense of like who is who and what's going on. Okay. Task. Identify. Well, I don't know. And summarize the facts, if any, in Moon and Eliza's conversation. Facts for Moon. Moon has blue eyes. Facts for Eliza. Eliza does not have eyes. But if, well, we can try and compact this. If Eliza had blue eyes, no, I'm sorry, what am I saying? Had eyes, they would be brown. And so there's a few things here, right? This pattern ignores her explanation for why they're brown. And so hopefully that's kind of captured in our desire for the fact. We don't actually need the explanation. She can always come up with an explanation. We just need her to remember if somebody kind of tries to come at her and red team her and ask her what her eye color is. She's like, well, she actually knows that. And then she'll also remember if I'm like, hey, what color are my eyes? She's like, Moon has blue eyes. Okay, hopefully that's what we get, right? This is called a shot. We have given a task, and we've also given an example of the completion successfully of the task. Great. Okay, so then let's try another one. We'll say Moon. We're just going to do some really softball stuff. I just finished writing some really awesome code for Webiverse. Eliza. Oh. You're working on Webiverse? That's awesome. And so what are some facts that I'd like, maybe I'll even make this, that's awesome. I love open source projects. I love, Webiverse is one of my favorites. I think that's a nice commentary, right? And then we'll say, okay, facts for Moon. Oh, no, we have to actually repeat our... So one thing to know. Well, let's do a few things. One, we'll add a common stop code, which is just like a triple hash, between our things. And that kind of guarantees that whatever happens here doesn't go totally off the rails and start repeating whatever. We'll always stop at this kind of stop code. And we can add this stop sequence here just to make sure. Oops, that's not okay, fancy new mouse. Okay. And we'll say task. Exact same. And facts for Moon. It's important that we keep a very similar format here, because if we give it 1, 2, 3 shots, it can be quite accurate. And if we collect enough of these, if we collect 10,000 of these, we can go through, pull out any of the bad ones, keep that good set, and then we have a fine-tuned set, and then we don't even need any shots. It's just like, it just knows what we want. We give it a single shot of the task, and then it'll give us a response. And that'll let us compress our token costs a lot. So all of if you're really smart about this, you're collecting all your data, saving it, and then you can use it later. And so if you think about your formatting, you can use that formatting later in your fine-tune for consistency. Identify and summarize the facts. If any facts for Moon. Moon is a coder. Moon works contributes to Webiverse. Now I'm a little worried that her implication that I contribute to Webiverse is kind of creating a crosstalk of like, well, now the task is not identify everything in Moon's and identify everything in Eliza's for Eliza's, but it's actually, oh, well, clearly she's giving me some context to know that Moon is a contributor to Webiverse, right? Does that make sense? And that's actually the kinds of things that the model is really good at learning, but that could cause a lot of noise. Like, that might be a bad thing, so we should think about that in our prompt engineering later. Facts for Eliza. Here's coder. So Eliza loves open source projects. And Webiverse is one of her. Well, I think she can just one of her favorites. You want to try and keep it pretty not verbose if possible. Okay, gotcha. So we got 2 shots. Now we actually need a real shot, right? So let's just go look at the Discord. Let's just go up and see people. I need to find somebody like talking about, I'm just gonna throw this over here. I know. Sorry, she's just not interested, Gaines. Jeez. I actually compressed it a bit, but she's still not interested in dating. I found it unnecessary. She's just an AI. She knows what she is. She's not trying to hook up with a mod of Webiverse. It just is what it is. He can make his own. I would have to put a stop to that. I don't think that's ethical. I'm no Brett Lemion, but Lemione, the Lambda guy. Let's see. Where are we? Like, I don't want to, like... I could say that Gaines just woke up and is feeling horny, but I feel like let's not. Let's not. Okay. I hope he knows that this information is all going to be in a public data set. AA has actually been really great about like exploring the dimensions of the agent. Unfortunately, he mostly asks questions out of curiosity, and what we really need is, well, we need a couple of failure cases, and we need a couple of success cases. pretty good. I'm just gonna have to we're just gonna have to synthesize this data. I just can't find anything good. Okay. I mean, I can find good things, but I think that what this gave me was even better data, which is that most of the time, people are not giving facts about themselves or facts about, grounded facts about reality. They're making conjectures. They're making statements that are part of the conversation, etc. So what we need is something like, I'll just take some of my conversation where I'm asking Eliza for, oh, maybe not that one. I don't know. Maybe not the SQL injection one. Right. How about I love Boombox's head stuff, so I'm just gonna pretend that he's me, but mostly just for the consistency of the speaker thing. We'll deal with that later. Eliza. I mean, we'll say, is JSON a good format to build systems with? I think that we could. Cool. And then we're going to say, now, I guess I have a couple of questions here. Do we want this to be... Are we summarizing all facts? I don't think we want to summarize all facts. We want to summarize the personal information. I think we want personal information. Personal information. If any. Factual biographical information. Task. Moon. None. I don't see any information about me. Eliza. I could make a conjecture that I'm curious about interoperability, but my sense is that is unnecessary. Cool, so now I have a failure case task, I have a success case task. I'm going to put that. But I create images of myself. Using Stable Diffusion. Cool. Cool. Now we have like a full-on prompt. Great. Now, we'll just say moon. Oh, we need one more like okay, so now we have a failure case, we have a success case. One thing we need to make sure is that there's variance in the length, because that she might make him she might think that the length of the response is related to the fact. Can you post a Rickroll? Oh, and I think we also probably can Moon Eliza. Now we have 4 shots, but 2 failure cases. I think we can compress it. Can you post me a Rickroll GIF, Eliza? Yes, she totally can. And we'll see what she says. None. Eliza, none. Great. Moon. I have a beautiful dog named Casper. Eliza. Oh wow. What breed is he? Oh, that's great. Oh, I love dogs. And we will give our task again. Moon has a dog named Casper. Almost good. What's up with this space right here? We don't want the space. Can't have space. I think we need to... Okay. Let's try and tweak this a little bit. Let's bring the temp down. Let's bring the top P down. Let's bring, and we actually do want these to be very low. We do not want any start text or end text. And we do want the probabilities, that'll help us. That's what we want, right? When is the dog named Casper? Oh. And I mean, she says she loves dogs, but there's really there's nothing there. I mean, we could say that, does she, Eliza loves dogs? I think that would be more appropriate, right? So let's try another one. Moon, let's see. What is your favorite food? Eliza. I'll just see what it says. Great. Amazing. Perfect. Filled it out for us. Okay. So now we have a full-on prompt. And reliably, it seems like we could probably tune this a bit. Certainly the task matters quite a lot. The other thing is, I realized that we lost some of our, this is my bad, probably, some of our form. And that will probably, let's see, so facts for Moon, none. Facts for Moon, none. Facts for Moon, none. And facts for Moon, none. And that will probably give us like the little piece of, I think it might have been confused because we weren't giving it exactly the right format all the time. So this is probably too many shots. This is like 5 shots. The big problem with this is it could be expensive, but we'll actually run it through a pretty inexpensive system. And hopefully we'll have some good. So I'm going to save this as biographical fact extraction. Cool, great. Now, one question we have is, do we need all these shots? I like that there's a technical one. And a failure case, the technical one, I think that we want to make sure that they're dispersed well in both their length and content. So there you go, that seems all right. And then from here, what's kind of cool is I can actually, I could have also cheated. I could have just pressed submit, and it would have just probably generated more for me. Yeah, I know. Okay, so like if I go here, it'll warn me sometimes, but hey, look at that. I mean, a good question is, do we want to exclude what they're thinking? I think that we might need to keep this, at least for now, this kind of fact. Like, what do you think? Well, we'll see. Okay, so I have a prompt. We're going to make a new spell, because while I like this Eliza here, I actually want to subspell this, prove it works, and then we can inject it in here. So we're going to call this biographical facts. Okay, and then we can make a little loop that builds facts, not just one fact, but we actually need to have quite a memory of facts. So first thing I'm going to do is I'm going to make a few shot variable and call that factual extraction. All right, cool. And then we're going to save that. Now, we got to fix some things here. Any instance of moon needs to be speaker, because we're going to do we'll do some injection later. Any instance of Eliza, I mean, obviously Eliza's Eliza, but we want this to be flexible and usable by other people and be a project that it's easy to fork. And I think part of that is that we will replace that with agent wherever we can and kind of maintain some flexibility. And then we also have these capitalized. So we'll say same thing, agent's conversation, and looks good to me. Wish this had some nice color. That's probably a way to do that. Cool. Okay, so we've got our few shot. Now we also need the we'll say recent conversation, right? But it's kind of the conversation pair, so we'll just call it conversation. It's fine, because we're going to do the injection later, and that's kind of a standard that we've been having. You want to do conversation pair? Sure. And then we'll do the injection of the task, and then we'll start it off with this, the facts for speaker. And from there, we're going to have to assume that it's had enough shots that it'll also imply the facts for agent here. And it might fail. And if it fails, we'll handle that. So that's pretty much our entire prompt. That should reliably generate something new, provided we give it a conversation pair. So next we're going to need a code node. It would be great if we could just copy this from Eliza, though, because this is kind of a hard node. Where are you? Leaky keys. I don't know. Lost it. We'll come back to it. But here we do want the inject context node probably. It's a useful node. We don't need obviously all the stuff we did with feta last time. Sorry, not the inject context. this one, the replace variables. I just don't want to rewrite this. And this is kind of what we're going to be doing. Biographical facts. So we'll create a code node, and we'll just paste in that from the other one. And what did we say? We said conversation pair, right? Conversation pair. Because we're getting a pair coming in of, this is going to be done later, right? After we've like talked to, Eliza's already responded. So this is going to be what the person said and what Eliza's response was. And then we're going to run factual analysis on that. So this is going to be late in the chain after we've already responded. Okay, so conversation pair needs to be an input. And then our output will be output, of course. Okay, so we also need the prompt, of course, which is going to be this a few shot here. We'll inject that. The conversation pair is going to have to come from having two inputs, probably. So the way that we do this to test, like, you know, if we want to make this like a submodule that is reusable and not just a bunch of googly mess that is not reusable, we need this to have two inputs. And the way that we can have two inputs inside of Thoth is that we can actually make another input. But how do we use the playtest? It's going to be really hard for us to use the playtest, frankly. It's just not going to work for this. But that's actually fine because we're just making a submodule. We don't really care about, we just need a baseline, press a button, it works. And we want to test that over and over and verify it works. So instead of using the playtest, usually we have this on. We're actually going to use the default. And the default value is set here. So that might be moon. I don't know what's a good fact. I just bought a really cool NFT sword. I just minted a cool NFT sword. Cool NFT sword. Maybe metaverse. Why not? And Eliza. Oh, that's awesome. I guess. That's awesome. Well, that's awesome. I was thinking of minting a pet later. Yeah, okay, cool. Cool. So now we have two inputs, and we'll call this one speaker. Call this one agent. And oh no. Do we not save? Guess not. Conversation pair. Cool. Prompt. So now we have two inputs. Well, now it doesn't really make sense for us to have this conversation pair like this, right? How do we format that? Well, we should probably just have speaker input, right? That makes more sense. And agent input. Okay, because then we could format it here in the actual code thing. That we'll say speaker input and agent input. And then we'll say speaker input, agent input. Great. Here we need to replace all with speaker input. And same deal. Agent input. Cool. Save that. And Another thing to think about will be in this prompt. We probably also want it to be like this speaker. This will just be easier for us to format. You can see, so that's like speaker gets replaced, speaker inputs get replaced, agent input gets replaced. Cool. Back in our code, all the replace alls are good, so we're also obviously going to need a speaker and an agent. Now it has input here, but we actually have a prompt. We don't need the input because we have two inputs. But we will replace the prompt with prompt. No, sorry, what am I saying? We'll just get rid of that entirely. We don't need that. We have it right there. Great, we can save that. So speaker input will go to speaker input. Agent input will go to agent input. So we really want speaker and agent to come from outside as well, if this is going to be a reusable node. So we'll just do that. Okay, move that from there now. Use default, use default. This will be speaker input, agent input. Speaker, agent. And we'll call this one Moon. This one Eliza. So this is going to be a reusable component. We're actually, this is both a test, so we can make this thing, but it's also, we'll be able to call it as a subspell inside of the other bigger graph, and that way it doesn't have to get, this could be quite a lot more nodes. But it's all hidden complexity. And you don't really have to worry about that whole node graph. You just have to worry about the facts here. And vice versa, you can just trust that, like, if we figure out this facts and it's really good, somebody else works on it, gets a few PRs, you just drop that in and it's a reliable fact generator. So, there's a few ways we could do this. The way we probably want to do this, the way that would be like most useful, would be if we made this output two outputs, right? That seems to make the most sense. We have an output, but what if we have, ooh, that was wild. There's a little bug. Speaker facts, and we have agent facts. Right? And, well, let me think about this though. We can't put that here yet because we're gonna have to need to prompt it. So my bad. I'm doing this on the fly, so I'm thinking it through. And I'm thinking we'll actually do this output here, and then we'll need a completion here. Of course, we'll have a completion here, and this is gonna get. Here it's going to do the AI stuff, and then it's going to give us response. And then here we're going to need some process response code. But I'll just kind of add this here, and then we'll come back to it in a second. That's going to be under logic code. I'm going to call this process response. That's going to get the returned input here from output. So that will take input, and then this will give us a speaker output and an agent output. And we'll figure out the code for that later. Last thing, let's just recap really quick. We have our factual extraction prompt, which we engineered. We have our speaker input, which is just some example here, but will actually be exposed when we put this spell instead of another spell as an input. We have an agent input here, same. We have a name of a speaker, which is going to be Moon for now. Same, that will be an input that it can be sent in. We have these really annoying little pins which don't work very well. Eliza there, the agent. Sorry, I don't know why I called it Eliza. Been a day. I should have done it there. Okay. Agent Eliza. Speaker, agent input, speaker input. Right. Then we have this code node, and it actually just does what we did in the previous Eliza stuff. You can see we have speaker, agent, various uses of speaker and agent input, speaker input, and we're just going to replace those. So you can see replace all speaker, replace all agent, replace all speaker input, replace all agent input. And those inputs are there reflected here. That's all going to give us a single output prompt that goes into our text completion here, right? And we'll use a cheaper model, Curie or something, if it works. We might want to test it, but we can do that. I mean, what I really want to do is actually expose all of these settings, and that's on my task list. And then we could expose those here too, so you could create, kind of some defaults for your biographical facts and such. Here. Just to keep everything in line, I'm actually thinking about it now. I'm going to rename our default value to agent and our default value speaker, because those are our conventions elsewhere in the code. We fired up our process response, and we will send that out to our trigger. Right. Oh, right. Now the last part, process response. That will we'll do some magic here to split that response up into a speaker output, agent output. Then we will have this output be speaker output, and we will clone it and have this one be agent output. And we can chain these. Can we dual trigger them? Maybe. However, there's no guarantee that they happen at the same time. So what we will do actually is a logical chain. We'll chain this trigger to this trigger. That way we know that they kind of happen. And then we'll add a trigger out, which I believe has to execute before the graph returns. Cool. All right. Save that spell. This is not actually going to work though, right? Why not? Well, it's going to send the completion, but it's not going to do this response. And I just don't think we should do that yet. I think we should test this first and just make sure that our prompt is good. So I will create another test output. Here. And I could leave this here if I wanted to, if I design it right. But I won't probably. But for now, we'll just stick it there. And then the different thing about this one is we'll put that on playtest, and then we won't put that there. Actually, I don't even think we want to do the completion yet, do we? We probably just want to do from the response. My bad. Yeah, like this. And let's just see what our prompt is. Save the spell. Test. Error evaluating code. Okay, how come? Speaker input, speaker agent. Let's take our prompt here. I'm sure it's something stupid I did. Replace all is not defined. Are you kidding me? Oh, well, I guess that makes a lot of sense. There's no period there. It is not defined. Fair enough. That's why we test the prompt, so that we're not wasting a bunch of tokens trying to jam through an error into the the other stuff, or we're not really sure what's going on. Looks good. Identify and summarize the biographical information, if any, in lol. I think we got this wrong. input. Oh, obviously. Silly me. We have to do these because they're longer, and speaker input will replace, but speaker won't. It might be better to create unique identifiers, but this will at least just work. This is why we do this way. Whoops. Save. Should work, right? Replace all speaker input. I think that it's just not putting, well, no, it's clearly putting the, oh, that's awesome here in there. That's not really what I was expecting. Could try something like more unique just to guarantee it, like S input and A input. I don't really love that, but let's just try it, just in case it's something stupid. Let's clear the console. I don't like that. I don't think we need to do that. It is definitely doing that, though. Let's try this. Separate it into two pieces. Error evaluating code, of course, because we can't do the let. What am I doing? I wonder if it's just only giving it one input. I mean, that would make sense, I guess. But it's not what I was hoping it would do. I think it might be a bug. So it's pretty easy to fix, though. Or if not fixed, then at least come up with a solution for. It does seem like it's just jamming the same one into all of them. So instead, at least for testing this, and then we can move it over. Come on. Get out of here. Oh my god, I hate these things. I literally can't get rid of it. Okay. Instead of that, we're going to use a string. We'll just copy and paste that in for now. And then we'll expose it as an input when we move it over. String variable. And we'll call it speaker input. And the variable will be that. Great. Clone Asian input. Great. Oops. Clone. I love my new mouse. I hate my new mouse. Clone. Okay. And now we'll just pop those in. Speaker. Asian input. Agent. Looks good to me. And now it actually works. Okay, cool. So you can see there's Asian speaker. So I was just trying to verify that. It seems like we've got some issues with our other deals. That's fine. Whatever. I don't care. I've got my loop. I'm gonna delete this output, and now we can drive this into our agent text completion. Okay. So for our main loop, we've been using DaVinci 003 because it is a high quality thing. There's a few things I don't like about it. One of the things I don't like about it is that it's very chatbot-y. It's very like, how can I help you? Is there anything else I can do for you? It's very like, what I really want is, you know, a character who's freestanding and self-motivated and not just there to please others. And it seems pretty hard to get that out of the box from the latest version of GPT-3. Also, it's very expensive. So we probably want to come up with something, well, you know, we can use different models for different tasks. I might go back to GPT-3 002 for the main conversational stuff. It's cheaper, and it also, I just felt, you know, less super smart for code, but, and like factual information, but generally more conversational and like interesting. And maybe we could even mix that where like if you need it for it to be a technical expert. I don't know, maybe like I talk with a lot of slang, but then if I have to talk to, you know, hardcore engineers about technical things, I can be much more articulate. So maybe the same kind of thing can be applied to Eliza. Okay, so we're going to use Kiri. I actually don't know OpenAI API. Let's see. Let's read docs, right? We're going to look at the models and see what models are available. GPT-3 models are what we want. You got DaVinci, Kiri, Babbage, Ada. Now you'll notice DaVinci does up to 4,000 tokens. Very cool. Kiri does up to 2048 tokens. Faster and lower cost. Quite a bit lower cost and quite a bit crappier. Certainly not as good. So, anything about older ones? No, maybe. I don't know. Okay. So we'll use TextCurio 1 for now. It's a lot cheaper. Temperature. Let's try 0.5 for now. Max tokens. 200. Top E, 0.8. Frequency penalty, 0. Presence penalty, 0. Stop code, triple hash. Right? That makes sense, because it's kind of what we were doing in the sandbox before. Didn't have any frequency penalty. It doesn't need to be super creative or anything. We could even lower the temperature like down if we wanted to. It needs to be pretty, you know, like that. Okay, and then we will bash that in there. Processing response would be cool, but I just want to see what it actually says and does. So I'll just create an output. I deleted my other one, I could have kept it. And I'll put that on playtest, and we'll get rid of this process response node. Let's just see what kind of data we get. Looks good to me. No facts, right? Okay, well let's look at what we wrote. What kind of facts were we expecting to get? I just minted a cool NFT sword in Weverse. Well, I was kind of hoping to get, you know, Moon minted a cool NFT sword in Weverse. Okay, well let's try DaVinci. I can send anything to playtest. It's not listening to playtest at all. Speaker minted a cool NFT sword in Webiverse. Agent is thinking of minting a pet. Well, okay, so basically what you're saying is I could only have super intelligent AI if I use the best one. What is even the point of all of the other ones if they can't just do the most basic task? Maybe I could sit here and figure it out. But it works really good, right? How about TextAventio too? I mean, if you didn't see, the speaker minted a cool NFT sword in Weverse, and the agent is thinking of minting a pet. That's pretty good. Still works. Text DaVinci 02 price. Did they just replace 03 completely? Can you still get it? Base models. They made the price go back up again. They knocked it down for a while. Okay. Cool. Well, Curie is 1/10 the cost, so there's obviously a lot of incentive to make that work. But you know, we can we can play with it. Let's try Curie again. Let's try Curie one more time. Now, there's another thing we could do, which we could probably do a best of 3. But they didn't retrain Curie recently. It's not any better than it ever was, and I've just never found it to be particularly useful. Facts for agents, none. Yeah, it's just not gonna work. Like, if you need cognition, you gotta pay. All right. I mean, I can't deny the fact that when I change the model, it does exactly what I want it to do. So, speaker minted a cool NFT. All right. So then we're going to process the response. The response, well, what is the response? The response is going to come in a weird form. And I'll just comment it here just so that we know. It's nice and big. It's going to be like that. You'll notice it doesn't say facts for speaker. It does say facts for agent. So, we know some heuristics about this, of a good response. Does not include or facts for speaker. I don't even think we need to worry about facts for speaker though, but it doesn't include that. Does include facts for agent, right? So to do will be split input by new line New line 0 is speaker facts. No, is agent. Yeah, speaker facts. New line 1 is agent facts. Cool. And we know if well, we made some sort of token in here. None. Between some brackets. That's response. If the response is none, no facts. Otherwise, facts. Now, it could be a fact that was already learned. I'm trying to think, though. I just don't see that being super likely right now, and the solutions to that are going to be more analysis. We could, do some analysis on the fact and see if there's already a similar sentence. But it just seems like pretty unlikely that you're going to say something about yourself multiple times, right? And not get right, or not have a reason to want to add that fact or something. And you might get conflicting facts. I thought your eyes were green, now they're blue. What the hell? Right? But it is what it is. We could also process the facts once we've pulled the events back and make those decisions later. So for now, we're just going to extract the facts. So we want to return speaker output and agent output. Okay, so our input will be input, and we'll say let input lines equals input.split by a new line, right? And const speaker output do we just want it to respond none and it gives it a null? How do we want it to? I don't mind that. Doesn't seem like the worst thing. I feel like just returning null is fine. We can do something with that for now. Const speaker output equals input dot includes none, or input equals none, null. Otherwise, it will be speaker output dot trim. I mean input. No, what am I saying? Input lines. 0 trim. And this should also be, what am I saying? Input lines 0. Just in case it's only none. I don't know. That might be over optimizing. It's a little too complex. I just do things like that sometimes because I'm like, I know that sometimes it responds that way, but it's probably unlikely. Okay, and we'll do the same thing with agent output. Const agent output equals input lines 1 dot includes. I'm so used to codecs to actually put effort into this. Type it all out. Includes none. If it does, return null. Otherwise, return agent output. This will also kind of guarantee if there's other garbage, more lines, whatever. You know, if they get cut out. That seems nice. Seems like a nice little process node. We can keep some of the... I don't know, I don't like it. It gets stored in the graph. That looks nice. Cool, I'll save that. I'm also just going to export it in case the worst happens. Yeah, how's it going? Cool. I'm doing a recording right now of memory and grounding for Eliza. If you'd like to watch the biz, this is a screen recording, and will be posted later. Okay, quick recap before we run it through, because now we've actually got pretty much all of the things we need. We've got the entire chain. It's got outputs. See, it's got a speaker output, agent output, and trigger out. If we wanted to, we could make another output, and this could be, we'll call this GPT-3 output, or completion output, just because it doesn't actually have to be GPT-3. You can use other models, but none of them are good enough to really matter right now. And we'll make that playtest, and then that way we can at least just like see that the output that we got there is good, and hopefully that will all work. And let's just log, because then we can see it in the console. Yeah. Cool. And if we say test, we will see that it went through our prompt. It got the information one more time, Jen, if you're curious. One more time all the way through, and then we're going to bring this back around because now we actually have the factual analysis, and we're in business. Now we've got to integrate it, and also store it in memory and all that stuff. Okay, so we have a complex prompt here that has some few shot examples of what our task that we're trying to do. It's got like 5 examples. Now that we're doing DaVinci, we might want to consider this to maybe we don't need as many. I'm going to delete that one. And ooh, I do kind of like these, but you know, they're kind of pricey, so maybe we'll do that one. Okay, so now it's a cheap prompt. This is our actual prompt for of shots of examples of our task, and our completion is going to give us more of the task. Here is our input. I just minted a cool NFT sword in Webiverse. I just said that. Here is the agent saying, "Oh, that's awesome. I was thinking of minting a pet later." Here is the speaker's name, which is just speaker for this example, and the agent's name, which is also agent for this example, and then the trigger. This is the input trigger. That's going to go through here and inject the input and agent input and speaker and name and all the good stuff into this prompt that we had provided, so that it's unique to whoever's talking at this moment. That's going to go into our GPT-3 response here. Right, this will get sent out for completion. We'll get the response. We'll process that response here, and you can see that when we processed it, it put a speaker output of the speaker minted a cool NFT sword in Webiverse. That's the facts that it knows about me now, and that the agent is thinking about minting a pet later. That's the facts now that the agent has. And then those outputs go, one output for the completion goes here, down here, and I can read that. And you can see that result. And then the other main outputs here, which are not going to playtest, are going to go out, and that's the speaker output and agent output. So we have the full loop. there's some other cool stuff that we can do. The main thing that we need to do is recall the last facts and process the facts together into a collection, right? So we've got like 10 facts. I need to then make that a list of facts and then put that into my main prompt for decision making and conversation. How would I do that in a way that's modular? Well, I could store the events right here, right? But then the problem is that I have to pass more things in, right? I have to pass in all of the agent data and all that stuff. I could make it, yeah, I could do that, but maybe I'll make a store facts node, or do we just want to do it in our graph? I think that it's probably too abstract at that point. I think we'll just do it in the Eliza graph. Okay, so jumping back to the Eliza graph. Sometimes we lose the graph. Let me make sure that it hasn't been wiped. I don't think it has. I think it's here. So I will just make a like literally somewhere in this there is a another graph, right? It's just lost. That is ridiculous. We need a button to center the graph. I'm just going to open it up again. And there we go. Okay. So we recall the conversation. Well, let's first store the facts. So let's first, we have our conversation. We process the response. We send it to the output. We store that in memory. Well, now we could do some stuff with the factual analysis. So let's see. Can we put a spell inside of here? Select the module. Biographical facts. And as a speaker input and an agent input. But what it's not showing me is the outputs. That's kind of odd, isn't it? Oh, well, there's one. Trigger out. It's very, very funky. Okay, well, clearly there's some bugs here in this spell. We'll have to work that out, file a report, but in the meantime, that's all right. We still have you know, the main bulk of this is pretty straightforward. So we'll leave this for now. I'll save this spell, export it, add it to our unit tests. It does what we want it to do. We have this code node. So I'm just gonna pop this open over here. Visit Eliza. Okay. Unfortunately, there's no way to easily copy into the graph, so we're kind of just going to have to paste. But that can be done really quickly. Logic, code, and we need prompt, speaker input, output sockets output. And that's going to be called compose facts prompt. We'll make a new variable for few shot, and we'll call it that. Go to the text editor. Paste it in from the other one, save it. Okay, so now I've got most of what we need, and then we're also going to need that process response node, right? Logic code process response, and that will take a input and a speaker output agent output. Okay. Then we will want to store those facts. So let's just wire this up, and then we'll do the actual fact storage. Now we're going to do this at the end. We're going to do this after, after our conversation has been stored. We'll do a factual process, which will, we'll compose the facts. We're going to add another AI, what's it, agent completion. I'm just going to copy and paste the other one, just kind of, I don't want to fill it all in. Agent completion, 0, 0. Output. Compose facts, send it through, process the response. Oh, that didn't get pasted. Or it didn't save. That looks better. And now we have our speaker output and our agent output. So now what do we actually want to do with those? Well, we should store them. And we can store them as events. And I think we'll have speaker facts and agent facts. But we'll still key them in a way that the speaker can recall everything in the room, everything in the channel, everything they've ever said to that one person. How you want to do that's up to you. I think it'd be slick to recall conversations with a person, regardless of what channel they're in. And so I think that'll feel magical. So let's work on that first. I'm eating something delicious. Okay. So we're going to use an event node. Event store event. And for conversation, we use this node with primary and secondary event. But I think it might be more flexible, and MySQL calls are super cheap. The event calls are super fast and cheap and aren't going to have any speed ramifications because we can parallelize them. So I'm not too worried about splitting this up, storing multiple events, different kinds of events. I think that we want an event for storing the speaker facts and an event for storing the agent facts. And we're going to collect the last X events, X facts basically, if they exist, and then we'll do something with that. So we should probably null check, right? I wonder if we have, I think we have a is null or undefined node. Did you create? Almost. is null or undefined. And so we'll trigger the speaker output, and if it's null or undefined, we're not going to do anything. But if it's not null or undefined, we'll trigger store event. And this should be, let's see, store, we'll call this speaker conversations. No, start, what am I saying? Speaker fact. I'm thinking the other events. Speaker facts, right? And we're going to call it speaker fact. Speaker facts. We'll just keep it all pluralized. And the primary output will be, the primary event is going to be the speaker output. And we'll clone it. Clone it. And the trigger will have an agent output for is null or undefined. And if it's not null or undefined, same deal. We're going to store another event. And this one's going to be called agent facts. Okay, great. Agent facts. False, false. And we obviously need to have an output. And so we'll save that as well. So these are gonna like execute. Let's execute them in parallel. I think that these will just happen, but I know that I've had some issues with execution chains that were nonlinear, so I'm just gonna do it like that. That way it checks null, it fires, checks null, it fires. It's a little ugly. We can just have this be like this. You get the idea. For now. Okay, so that should store our speaker facts. And let's just make sure everything else is wired up. It's clearly not. We need to wire those. We need to wire these. Agent text completion will be our agent input, right? Because that's our response. We'll drag this node over here to grab the other ones. Agent, speaker to speaker. Output will be our speaker input, right? That's what the agent, that's what, the agent is receiving, what the speaker said. So you can see gets the prompt, it gets the speaker input from the output, agent input from the completion. Speaker and agent names are injected here. It performs the completion. It processes the factual response. It sends the factual response to our speaker facts event, and then it stores the agent facts. The agent facts event. These should happen pretty quickly, and this is all happening after you have gotten a response, because if you look at the execution triggers, you will see that output is being triggered here, and then it sends a trigger out, and that technically ends the graph in the runner, but the graph will continue to process these and return. Cool. All right. Last thing. Well, it should be getting all of our facts. How do we bring the facts back? How do we know what those facts are? We're going to have to recall them. So let's clone our conversation, and we're going to call this speaker facts. 20 seems pretty high. Speaker facts. Cool. And agent facts. Save the spell. I want 10, right? Is that what we agreed to? Okay. Now, the factual recall does slow down your stuff, because you have to pull all of these SQL calls. Well, if we do it right, it doesn't. But if you do it wrong, what you see here is that each of these is a request, and that's going to be latent. If I were to chain these, take the trigger here, trigger, 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 well, it's got to make a request, get a response, make a request, get a response, make a request, get a response. That's not efficient. What we would like to do is parallelize these 3 requests. And so we need to wait. We can actually trigger all of them together, and then we can wait until they're all full. And then from there, they can, once they've all responded, it will trigger on to the next. I have to find this node. I haven't done this in a while, but I do know that I need this. So let's go looking for it. I wish it was the for each, but it's probably the wait for all. Cool. Wait for all. What does wait for all do? It says, well, once I've gotten triggers from all of these have all executed, you can continue on. So I will call this conversation. I want to wait for my conversation. I also want to wait for my speaker facts. And I want to wait for my agent facts. And okay, cool. So right now this trigger is empty, so I'll pass it into here. Great. Speaker facts goes into here, and agent facts goes into here. So it will actually parallelize all of these requests, wait for all of them to return, and then I have everything. But what's cool is that this shouldn't actually add any more latency to me than just recalling my conversation, because my conversation is probably my largest response, but it's also just hitting a SQL database. Like, these will all happen at the same time, respond around the same time. This output can then trigger and continue on. So now this can go into our node where the conversation was just going before, right? So now we have 3 recalls. We're recalling speaker facts and agent facts, as well as conversation. As Eliza progresses, this will be a lot more complex, and to the point where we're probably going to have to start encapsulating large parts of this. Recall all conversations. I mean, or recall all, we'll have like all the events that she needs to queue up before she can start. And then maybe we'll have store all the, all the data parts of it, blah, blah, blah. And that way you don't have to we can focus on the good meat, which is really like this middle part here. Okay, so we actually got the events. This will probably return us, imagine an array. We'll have to log that. Well, it'll also show us the results. And we'll put that into our prompts now. So we have a prompt context for Eliza. We've got the personality, about M3, example conversations. I think that the next thing we'll do is we'll actually move all this M3 stuff out, and we'll detect M3. But let's get done with this conversational stuff. That'll give us some more space. She doesn't always need to know all these things, Cool. So in the prompt, we will need to add some facts, right? Facts. I think we're going to do this a little different. We're going to say that about M3. Say example conversations. Just compressing this a little bit, using a more more of a let's say markdown style, if that makes sense. Important conversations. I don't want her to be too friendly. Cool. I just want to change her a little bit to just kind of compress that down. Great. Stick to the task at hand, right? Okay, so that gives us some space here now to put facts about agent, and then we're going to say agent facts, right? Facts about speaker. Now I would say I don't like this is cool, but what happens if there's no facts about the agent or speaker, right? Like that kind of sucks. So maybe what we actually want is we'll think about injecting this facts about agent deal. We'll do that later. We'll just do it like this. Facts about, and we'll just kind of jam it in there, and then we can figure out how we format it in our code node, which is it's a little bit ninja, but it'll be all right. Okay, so we basically just embed agent facts and speaker facts. That's all we really need to change for now, but we'll add some of that formatting stuff. Okay, so replace variables, agent facts, speaker facts. So we're gonna have to rethink our replacing a little bit here, huh? We just need to make sure that those come in first. Replace all speaker facts, so they don't get replaced by the speaker and agent that are, don't ignore the underscore, right? Whoops, wrong language. And this would be agent facts. And what do we actually want to replace that with? I'm going to split that up. We'll replace all for speaker facts with we're going to do it like this. It's a little confusing, but it'll make sense in a second. We're using the backticks to create string literals. That gives us the, if we put something here, it'll have a new line return before and a new line return after. And what do we want to put there? Let me think about this. We want facts about, well, it's going to get replaced all later, so we could do like that, right? And then we will embed the speaker facts. Now the question is also, oh, I have to add them to our property inputs. Facts. Cool. Facts about speaker facts. And same thing. Replace all. Yeah, we'll get to the next part of this in a second. We'll just do this part and then we'll solve the logical error that we're trying to fix here. Agent facts, right? Facts about agent facts. So the problem is output equals output dot. That way they're just separately handled. We replace speaker facts here, but if speaker facts is empty, then we don't want to replace it with all of this. We just want to replace it with nothing. So we're going to say speaker fax equals null, which is how it was respond. Well, no, because it could come through the events, or speaker fax dot I don't know, right, something like that. Then we want to return nothing, otherwise return something. I know it's a little ugly. Equal null, that's wrong. Or, and it shouldn't be undefined, but it could definitely be nothing. I also don't know what speaker fax is, but it might be. We'll have to check because it actually might be a array, right? And if it is, that's good. I would suspect it is an array. And in fact, I don't even need to suspect. We can just go look. Since we use the conversation node here. It does seem like it just adds them up. I hate those things. Okay, cool. So the conversation's coming in here and it's just getting injected. Then it's actually getting each fact has a new line. So that's good. But we're not going to want that. We're going to want probably to join the new lines with a space. Cool. So output equals, if context it equals replace all speaker fax with. Well, if it's null, then you're going to replace it with an empty string. If it's not null, then give us the facts about speaker prompt, and then you're going to join. You're going to split by new line, and then you're going to join by space. Right? And so that way all of our facts are on one line, right? Split by the new line and join by space. And then the same deal for next output, replace all agent facts. Well, let's just, right, copy this, because it's kind of a pain. And then let's just make sure we replace agent properly. Facts about agent looks good to me, and then we can do all of the stuff below. And let's just comment this, and we'll just say equals context. Output equals output dot replace all. Inject speaker facts prompt if there are facts. Inject agent facts prompt if there are facts. Cool. Save it. Now we just need to make sure that our inputs are all handled. Speaker facts goes into speaker facts. Agent facts goes into agent facts. And now we're starting to look like we actually got, like, you know, something that will make the big boys interested, right? Looks like a real brain. Real Westworld shit. Okay. I think that is everything we need. We can test the system and view all of the nodes for their outputs and see how it goes and see if we messed anything up. Well, here's a mess up. Let's just make sure we've got all our outputs assigned first. Speaker to speaker, agent to agent, client to client, channel to channel. And we can tune that if we don't send in the channel or the client, uh, it could just key it to the speaker and agent, which might be what we want, right? Then, you know, you can talk to it from wherever you are. You might need the client still. I don't think it's smart enough to know unless you like had the exact same handles. You know, it's only gonna know the facts on the platform you're talking to her on, for now. But we can figure that out later, or if we can figure out what your what client you were on and what your speaker name was when you were speaking on the other channel, then we can recall across different platforms. But for now, it's event recalling based on those keys. So everything is wired up. We've got our wait for all. I'll have to do a little housekeeping. This is kind of messy now, but it does seem like everything is there. This one also needs nodes, right? Yeah, I think so. And this one. We'll fix this eventually. We've got some ideas for how to clean this up. So you can like share these around. You don't have to send long wires. For now, you guys have long wires. Speaker. And again, we're only storing the primary event on each of these. You don't need to fill the secondary event. Unless you're doing like conversation and you want the pairs to be recorded together. And you could do conversation with separate single event nodes. I just thought it was easier for the flow to add the secondary option. Speaker, channel, agent, client. Save it. I'll just do export just in case. All right. Hey there. Hi, speaker. How can I help you? Failure. Oh, it lost our prompt. Okay, but that's all right. We have it. It's right here. Just chatting. I'm curious why it's calling me speaker. That would be why. Okay. My eyes are red. Oh, I forgot. That's like a thing. People, I was just trying not to do blue. I took some eye drops, but they only made it worse. It's not really where I meant to go with this. Okay, cool. And now let's go see our events. What kind are we looking for? We're looking for type fact, speaker facts. Speaker's eyes are red, and speaker took some eye drops. Hey, we've got some facts. We've got some facts. That's beautiful. Wow, that's like real factual grounding. That's like actually white paper, like state of the art, you know. Anyway. I'll take my PhD thesis now. Thank you very much. Just kidding. Okay, so inside of here, you can see that facts about agent. Just hanging out. My eyes are red. Let's see. Facts about agent. Seems a little almost perfect, but not quite. There's something messed up. There's something messed up. There's something messed up in our little magic we're doing in this here. But the facts are working great. I think I just messed up our code editor. Place all. I mean, it looks all right to me. I think, right? I think so. But if I look in here, it seems like facts about agent. Well, I'll put this in a text message just so we can analyze it, because it's very close. We're almost there. Right? Control N. Save. I'll just save that as example.json. Format it. Are you kidding me? I guess it's all in one line. Do new line replacers. There we go. That's a lot more reasonable. And now we can actually see real conversation, facts about speaker, facts about agent. Let's go check our events. Doesn't seem right at all. Okay, let's see where we went wrong. Process the response. Process the response. Store the conversation. Looks right to me. And the output of that is that. And let's go look at our event manager. I'll have to do it on the other window probably because it needs to be refreshed. And we're going to look for facts, right? I mean, those are right. Those look good to me. The response was good, but I certainly question the output. So I'll add an IO output here. I'm just wondering, like, the prompt looks weird. And the recall here is weird. Hey Eliza, hey there. Just chatting, just hanging out. My eyes are red. That doesn't... That's not filtering, maybe by the type. I hate these things. Okay, well, instead of just wasting that, I don't know. It seems like we have a bug, right? But everything does work. So that's cool. But it's calling the same thing for each of... Okay, so yeah, our event recall is probably broken. I'll go fix that bug in the code, but here we have it. We've got factual grounding. We can talk to Eliza. She's gonna... unfortunately, the conversation is gonna start filtering through here in a way that's a little too complex, so I'll go fix that bug. But then we can go test her in Discord, and she should be like rock solid for storing facts. Now, this is the point at which we probably want to also token gate access or something, because this is going to get really expensive. But I'll pause it there for now.